Hello and welcome to WMI Stole Your Cat. This is a practical look at WMI defense and analysis. The goal of this talk is to bridge the gap of defenders to understand better how WMI is used and misused, and hopefully provide new avenues for defenders to better understand what is going on with their environment with tools that are already existing, aka WMI. There's a lot of acronyms in this talk, so I'm sorry in advance, but hopefully all of them will get explained, and the first one's probably what is WMI, but we're not quite there yet. So there are also a lot of cats in this video. No cats were harmed in the making of this video, but it should be a fun video. I would say talk, and I probably will say talk because normally this is an in-person event, but as far as that goes, we're not there right now. This is all virtual, and we're going to be just video recording. So who am I? I am sometimes spicy, but by day an incident response consultant. And this allows me a perspective into some of the very interesting challenges that WMI poses for defenders. And defenders have this particular challenge of identifying and reducing risk when the system itself just has this WMI just sitting there. It's a capability, it's a feature built into Windows, much like SSH on Linux, but all you need is valid credentials in Windows to use it, and it's not really known. If you're running an SSH server, you usually know it's there. Not so much with WMI. I am also a perpetual tinkerer. I work with all sorts of things. You may have seen my talks on voting machines and ATMs. Those are just two of the things that I most recently tinkered with, but if it runs an embedded OS or system, I'm there. I'm working on it. I'm also a perpetual volunteer. I work with the collegiate pen testing competition and the collegiate cyber defense competition. Both of those are very fun attack and defense and allow me to see a very different world than day job, a day job allows me to see. So the agenda today is we are going to be going through the background of WMI or MI. So that's Windows Management Instrumentation and Management Instrumentation, and how it basically functions. Understanding the defensive measures that we can put into place, as well as understanding how to use Windows Management Instrumentation as a defensive tool, as a forensics collection tool. And finally, we'll be exploring how the offensive tools and techniques look and work. One of the most interesting things about this is that WMI, in the examples we're going to be giving, may look very offensive, it may look like something malicious, but in reality, we are actually going to be working with it in a way that can be both malicious and good. So this should be a lot of fun. And it goes without saying, there is a lot of previous work on this. Back in 2015, FireEye came through and just dropped a ton of data on WMI. Previously, it had been kind of obscure unless you were a really good system admin, but WMI was just presented at Black Hat and said, here is this problem. And I really have to give credit to them because the work they've done and continue to do, they dropped one more recently. Literally, it's called They Came to Drop FOMB, but they've done a lot of work. And so if you haven't seen that, go check it out. It's some very good research, and it's something good to build upon. And it's been about 5 years, so it's time for another talk. This is WMI, and this is going to be going over some of the common problems we're seeing today, not 5 years ago, but right now. Now, you may be wondering, what is WMI? That's a good question. Well, it's a modern component built into Windows. That much is probably clear. It uses a pseudo SQL statement. In much Microsoft and Windows fashion, it's like SQL, but not quite. You have a where statement, and you have like, and you have comparison operators, but they just take it and changed it just enough to make things annoying. Um, it's divided into namespaces, and namespaces are essentially objects, and you can have sub-objects within objects. The namespaces provide a way to access information centrally from monitoring, management, configuration, but each of those can have sub-objects which can have similar capabilities. This allows people to add components later, as well as very structured and rigid formatting. You can be looking at some specific areas and not have to worry about duplicates or the wrong information getting set. So WMI is very powerful. Some few examples are process monitoring, scheduled tasks, services, CPU, memory, antivirus info, battery info, UPS info, configuration settings, installed programs, and this is all based off of the SIM model, or the common information model. I may say interface during this just because everything else is just confusing with acronyms. But this is a basis of an open standard. Microsoft is pushing towards SIM versus WMI, so a lot of the tools are similar, but they're just different enough that it causes a problem. And you may be wondering, well, when did WMI exist? I'm sure I haven't seen it before Windows 7. Well, the answer is that it's been in existence since about Windows 2000. It was available as part of NT4 as an optional component, but it was optional, so we're not really counting that. And about at the same time when Microsoft said, hey, PowerShell is going to be the future, I believe that was around 2006, 2007. Shortly after that, they said, hey, we're going to integrate it. And they made WMI a very tight-knit component in PowerShell. The basis of a lot of PowerShell commands are WMI queries. And similarly, PowerShell has direct access into WMI. There's a lot of capability to query, register, set, more so than the old command, which is WMIC. So as of more modern versions of Windows, the 2015 era of Windows or newer, there's just under 50 namespaces that are built in. And in reality, there's probably many, many more than that because it is nested. It it depends on where things are at. Now, I put theoretical, but the first practical exploit of this that really gained a lot of notoriety is Stuxnet. I'm sure there's others. More modern variant of that is WannaMiner, which has some very creative ways of doing persistence. It's not just the standard persistence that you see, it's a lot bigger and more annoying. But I'm sure you don't want to just have a history lesson here. It gets kind of boring. So what we're going to be doing is getting started with actually working with WMI. So WMI essentially has two components in it. The first one is internally. When you're using Windows components like task list or get process and things like that, underlying component is actually querying WMI to get that result back. And then you have the legacy components, which is WMIC. And WMIC actually is a very powerful tool. It has, in my opinion, a very easy to use and look at interface for querying, getting information and help. But you can compare on the left and right. Task list is on the right, and WMIC listing process is on the left. And you can see that a lot of the same information is pulled out of that. And from that information, it gets prettified in task list, but it's essentially the same information. And if you turn off WMI, you break task list. The other legacy component is VBScript, and it's still technically supported, but the way they're pushing towards more PowerShell-based, capabilities, configuring and running stuff. So that's get WMI and get sim, that common model again. And then finally, there's the WMI Explorer tool, which is a third-party tool, but it is very, very nice to use. From this tool, you can see the namespaces, subnamespaces, and queries that allow a operator to see a lot of the information that's there. And from this, you can see the actual nesting that's taking place, and you can see the path and all the descriptions and all this information that's built into WMI that allows you to do it. And just from this interface, you can see there's like the common model, like common sim log, the privilege namespace groups, and then below it you have actual security logs, you have the sensors, and it just keeps going on. The default one is the root sim v2. That's where the basis of a lot of the information is. And below that is where you can actually query a lot of the actual additional capabilities that WMI has. But you may be wondering, why is all this seem just so open? Like anyone can query these things. You can just ask what processor list. Well, the answer is yes. And Microsoft was like, here you go. A lot of the capabilities here and a lot of the persistence mechanisms have been actually, if you take a look at how they're built, they're kind of bottled up. The malicious WMI is used very similarly to the way the official documentation uses it. So if you take a look, there's two main areas that get misused. Talks about WMI get lifted and used as malicious, and then the actual WMI documentation, you're like, sure, documentation is going to get misused, but literally Microsoft provides the guidance directly on how to create a persistence module, and here's that screenshot. This is from the Microsoft website, and it gives you a pretty good idea of what's going on. Now, the three main components for persistence that we're going to be seeing time and time again are the filter, consumer bind, and binding. And each of these are different components to look up, do a trigger, and then put them together. And this is how essentially most persistence done. Auto runs does have the ability to see these, but as we keep saying, WMI is nested, so you may not necessarily see all of these just because it's in the it doesn't have to necessarily be in the same subscription area that you would expect. So why is WMI so powerful? Well, as I was saying before, it's essentially the equivalent of SSH or proc, depending on where you're looking at, but proc isn't network exposed. It by default, the WMI is connected via the DCOM ports, which is 135, and then you'll get a higher level port, 1024 through 65535, depending on the version of Windows. The only limit on who can access this is if you have valid authentication. If you don't have valid authentication, you're out of luck. But if you do, and that can be anything from a network account to really anything, you can get in. DCOM is basis of a lot of other capabilities. If you're seeing 135 and you're like, huh, that seems familiar. Yeah, it's used for a lot of different things. And just like those other capabilities, DCOM configuration, DCOM CNFG, allows you to add or remove capabilities for WMI, where you're setting it to listen on a specific report or port, which it does have the capability, 24158, but otherwise you're very limited on what and how to block WMI. WMI, and this is the DCOM configuration where you can see you can add and remove permissions, security groups, and things like that on who can do what it normally runs as, and the default authentication level of who can do what with WMI. We'll get back to that in a second, but back to the communication. Of course, Microsoft was not done with the different acronyms. You got WMI, DCOM, SIM. Well, there's more. There's the WBEM, the Web-Based Management, Enterprise Management, which is how it's got to give Microsoft actual credit to this one. This is an actual open standard that's used across enterprise environments. A home computer is not really going to use this too much, but if you're in the enterprise and you have enterprise appliances and tools, you probably will be seeing this and you probably actually use it. The protocol is fully documented, but good luck actually fully understanding it. It's very confusing and it's just going to make you angry. So the one big challenge for this is that WMI, while it's a Windows-based tool, and you can see the example of get WMI object where you could just call computer name and you're there. The actual challenge is that the tools can also run on Linux, so a attacker doesn't even need to actually run anything on the system or on a Windows system to be able to exploit. So you may be thinking, well, there has to be a better way, and of course Microsoft has thought of that. They have a more modern version of WMI interfacing. The legacy approach, which is legacy, is the DCOM-based approach. The more modern one is based off of WSMan. Unfortunately, I don't know the acronym for that, but the other part of it is PowerShell remoting. You can enable the WMI to run through WSMan, eh, or you can enable PS remoting, or you can enable both. It's very flexible. However, you cannot so easily disable DCOM and disable the communication over DCOM. And there's one other caveat for doing this with the enhanced protocol. It's more secure, but WSMan does not support the classic WMI queries, such as what WMIC does. So while you do have all the SIM interfaces, some of the legacy ones aren't available. And while they're mostly there, again, SIM can only, not can only, but it's more used for querying than writing. So you have some challenges when you're moving to more modern stuff. And then you may be wondering, well, can't I just switch to, just switch off WMI? Well, the answer is maybe. Maybe if you're brave enough. The problem is you will break a lot of small things where you least expect. Remember, task list uses WMI. So does the service panel. Service management uses WMI. Other components, such as antivirus, use it internally for querying different installed programs and other things like that. That will also break. Or tools that are just running in general to try to get system information may also break. So this poses a genuine challenge to operating with WMI, because if you disable it, those things will be gone and you may not have it run as expected. This is more common challenge with vendor tools. Enterprise tools often use WMI just under the hood because they can query it. So you have to make sure you're careful with what you're doing, because if you don't, you may end up having this all disabled and then your tools will also break. So there's other ways to deal with it, and that's what we'll be getting into. But you're probably here to tinker. So we're going to be going over the different components of WMI, and some of this may be very list and encyclopedia-like, but don't worry, this is more of a reference, so you can come back here and take a look at it again, and not to fear, it's all documented, described, and this is, again, on the Microsoft website, where you can take a look and see all the information that you need to implement your own. But we're going to be starting with consumers. Again, these are the three components to making standard persistence. A consumer is is a triggered event. They take in the event, and Microsoft, I'm sure, had very good naming ideas behind this, but it gets confusing very quickly. And the fact of the matter is the first two on this list are the primary ones that attackers use, malicious uses at least. ActiveScript uses like VBScript to trigger an event. Command line event consumer triggers an actual command line event. So this can trigger PowerShell, it can trigger like command prompt or anything else that you want it to. And then you have your other ones that are less used, but more of a system admin perspective. Those are the log event consumer, the NT event log, where it can actually write to the Windows event log, and then the SMTP event consumer, where you can actually send mail. This one, in theory, can actually be more of like a canary, where if someone removes your consumer that's detecting malicious consumers, you can trigger that event, and then you now see that someone did something, though that could get pretty spammy, because again, a lot of enterprise tools do all sorts of modification with WMI. Because WMI is extendable, it's very likely that a enterprise tool is adding to this. Also, drivers, a lot of things like Intel actually, for example, if the Intel NUC adds its own WMI. Anyway, you then go on to your events. The events there's two types. There's intrinsic and extrinsic. Um, this gets confusing because intrinsic, for example, has a lot of different components where they respond more to structure. Um, these are more like the deb like net interface, trace, and things like that, where you're responding to the actual change of the structure within WMI, the objects. They're short-lived, and they happen within the purview of WMI. So if you're interacting with them, they only have like a very short polling period, so you may miss an event. For example, why you see on some of the persistence, like, is the time between 3, 5, very short period of time, because they don't stay long and they roll over, and you have to pull them. Extrinsic are OS level host changes. This is like disk changes, registry changes, um, and other events where something has changed. It's a trigger. Um, And so these are a little more challenging to look at, but they also are very powerful, and you can, take a look at them. So getting started with WMI, we want to probably start querying, right? So with WMI, what we want to do is, actually I skipped it, but here are the actual events for WMI. This is directly from Microsoft, describing the different intrinsic and extrinsic events. So these events are described here, but you can actually go to Microsoft's documentation to take a look. And it gets confusing. You can mix and match, but again, because my WMI is so flexible, it's kind of uh, you can see some of them in both. Um, but when we're starting out in WMI, the key thing we want to do is take a look. So if you start with WMIC, for the most part of this talk, we're going to be looking at WMIC because it's just very easy to interact with. It takes all that documentation that WMI Explorer has and puts it into a very pretty list and makes it easy to use. So from this example, I did a query, you know, a question mark on WMIC, and you can see from this, there's things like network interface, the OS, the page file, things like the accounts, temperatures, time zones. Some of these are editable, some of them are view only. And so you can take these and then do subqueries on these to actually find out more information. Most of these are in the default root. Others are in other locations. For example, AV is located in its own area, especially Defender, but those are also accessible. So you can see that the capabilities here can be expanded upon if you imagine for a second using things like PowerShell or the SIM interfaces. These can expand on what you have and you can format and look through them. But from raw WMI perspective, WMIC is the true and proven standard. There is additional interfaces that aren't as easy to use with WMIC, such as the standard registry provider, which allows you to do registry modifications remotely. For example, if someone turned off remote registry, but you had WMI access, you could insert registry keys or change them or update them to a form that allows you to do what you wanted to do. So the interesting thing here is the parity. So for example, I'm shortening get WMI to GWMI because it doesn't fit fully. You can see how it wraps around. Get sim, there's no gsim, so I had to put it in full. But essentially the goal of this was to demonstrate the parity that the namespace 132 process is queryable from sim instances or WMI instances. And you can format it in PowerShell just as normal. And the parity command in WMI, so get process, and then you can see 132 get process. They're doing the same thing, the same query, it's just a different command to look at the different information. You can query services, network interfaces. You can actually set network interfaces from WMI, such as setting DNS, setting routes, and adding and removing, and all sorts of things like that. You can also adjust the startup. This is only one area of Reg where it stores it, but you can add and remove things there and do a rough approximation of what's there. And similarly, there's another gotcha with get scheduled jobs. It is not what you think it is. It's not scheduled tasks. And when people are starting out with this, they think, okay, I can get all the scheduled tasks, or I can insert into scheduled tasks. No, that's a totally different interface. And so what in reality we're looking at is at commands. The at command in Windows is the 132 scheduled jobs. These will run at some point in the future, possibly reoccurring. It doesn't mean that it's a scheduled task in the same structure. So there's a very big difference. And so you may not see a lot in here, but you can use it just the same way as a scheduled task. So we want to get some more practical examples. And I've done a lot of horrible photoshopping with cats, so I'm sorry in advance. But okay, so the big thing here is process. I'm going through a couple of different things, but in this example here, we can take a look at the processes using WMIC process. If we go back to the previous slides for a second, where you could see the helpful hints. Hold on. Oh, okay, it's just going to go all the way back. Maybe stay here. Okay, stay here. You can see the startup commands again, but you can see process management, product management. The queries here are shortcuts. They're what's known in WMIC as aliases, because nobody wants to type Win32 process or Win32 service, scheduled tab. They want it simple. And so WMIC makes all these aliases available. So when we're doing them, that's what we're seeing here, and we're also seeing at this point here. And I'm not going to jump around the slides anymore because that was a horrible idea, but you can see we can do queries. For example, with this one, we can see we killed Notepad. They weren't good notepads, but they were notepads. And you can see process termination successful. It returns what almost looks like a JSON object, but it isn't. And you can call terminate, or you can call open, or you can call stop or pause, depending on the different endpoint that you're interacting with. So the other side is similar. Here's an example of the delete task or action. And this is a service that was created, and I've done this remotely from another system. You can see the username and password are all that's specified here, and then the service is deleted. No interaction or visibility was really seen on the system that the actions were happening. So this is where it's a very powerful tool for an administrator, but it's also equally powerful as an attacker because it doesn't have that documentation there that you need. So one of the really cool capabilities of WMI is it has the ability to query what's called the security center. This is not the security center in like Windows XP or 7. Instead, this is the security center endpoint, which allows you to query a lot of different capabilities built into Windows or externally that are securing Windows itself. When you query this, it will return, for example, the antivirus product, and we can see if what antivirus someone's using, if any. In many cases, most people will leave Defender running, so you'll see 2 antivirus programs on here, but really it'll query what's here. And the challenge to this, though, however, is that this is only available on end consumers, so Windows 7, Windows 8, Windows Vista, if you're still using that for some odd reason, or Windows 10. Servers don't really have this capability. It's not clear why Microsoft didn't include it, because defenders need to know what's running on, servers as well, but they didn't provide it. But because we now know that the system is running Defender, we can start tinkering. So, for example, here we can trigger an exclusion add, for example, for all of C. And in Defender, any path is recursive. So if we do all of C, we've now whitelisted all of C, and now you don't need to worry about any malicious detection. Or we can exclude all exe files. The add versus set endpoint on here in Defender, because of their add-on, what are called object files, MOFs, um, because they're defined what these capabilities do, the calls, add in here appends, set overwrites, and you have to have it in a specific structure. So it's not really feasible. If you want to do something where you're appending or resetting, I should say, in its entirety, it's easier to delete and return the data by capturing it. Just an interesting note there, but it may be helpful for someone. This is another fun one. You can see we are disabling script scanning, and I think I used the wrong screenshot on this, unfortunately, because it was disabled, but that's no big deal. You turn this in, you can disable real-time monitoring and script scanning. And what this allows you to do is actually turn off the antivirus. You're turning off Defender, which then causes no announcement or no notification. It's just off. I'm sure it'll come up later, but because you're disabling real-time monitoring, you also disable ransomware protection and a bunch of other different tools in Windows that will just automatically get disabled because it's off. And I'm trying to move to the next slide. Okay, there we go. That was weird. So with this, you can see the antivirus enabled is true. We can set that to false, and we can just turn off antivirus in its entirety. That's kind of obvious though, because you then get the alert that says it's completely off. But some of these are not settable because you can see this is, as well. This is the MSFT MP computer status, not preferences. So this is where things get very confusing and very challenging quickly because you may see things that you want to set but you can't. But you can try and do sorts of things. I believe this one did have a set endpoint. Um, but if nothing else, you can go back and just turn off the script scanning, and disable real-time monitoring, which definitely does work. Enumeration in PowerShell, this is very easy, but in the case of WMIC, the way to do this, this is you take the tokens and you write them to a file, then you take the file and transfer it to another file. Because of the formatting challenges with Windows, what can happen is the namespaces it'll have the wrong line encoding, which then causes the batch for loop not to run. This is just a problem because we're running it in batch, but if you want to run it, also it ate my quotes, I think. But anyway, if you want to run it in batch and you want to use WMIC, this is one way to do it. And this is where you could pipe in and read in the data output from one and use it for another command. Of course, it's a little easier with PowerShell. You just have loops and you have actual code that, well, you have stuff that looks like code that makes it a lot easier to use. For example, this recursive function that was on PowerShell.com, I use this all the time. It allows you to get the entirety of a namespace, and it's recursive. Very, very helpful. There is another one that was on Reddit. I will post it on Twitter because it seems to have gotten very obscure, but the one that was on Twitter basically lists the entire tree of WMI, and that's extremely powerful. So let's take a look at another thing that we can do. I don't know why you would want to do this, but if you ever wanted to, you could disable all the services on a system. This would take, for example, WMIC service where, and then you take in the key. In my case, I was looking for start mode where it's set to an auto, and I immediately stop the service and set the start mode to disabled. What this can do is then turn off the service and prevent it from running again. You can do this similarly with the service QC command, and in some cases that's more sticky because WMI and all these things are bolted together in such a way. Doing certain things from WMI doesn't actually trigger the expected result. For example, WMI has the capability of creating shares, but that capability was removed at some point before Windows 10. It's still there. It still looks like it's running. It returns a value, but your share doesn't get created. So I'm not sure if Microsoft is trying to limit the capabilities that WMI can do, but it is getting limited. Here are another couple of dumb ones, but cool ones. You can trigger OS reboot or change the date and time on a system from WMI. And these actually do work. They're not broken. You can see how the actual object file is transcribed in WMI, so you can see that it has the int and all that stuff. Setting it into the correct format will allow you to set those values, trigger them. For example, if you wanted to do this, you would do call reboot or call Win32 shutdown. And it would call that actual function, which triggers the internal capability to reboot or shut down. PowerShell, it's similar. Computer name and things like that are also similarly set versus PowerShell and WMIC. But that's where it's at with those areas is within the OS area namespace. Similarly, user account doesn't allow you to set accounts, but it does allow you to rename accounts. So in this case, I didn't specify any queries. So what it did was just changed all the full names to LOL. I don't know why anyone would want to be that noisy, but you can, in this example, see the full path of the query, which would be the computer name, the root, SimV2, Win32 user account, domain equals name equals. And so that property has gotten updated. You can't rename the account name and you can't add accounts, but properties underneath the account are settable. So you've heard me mention MOFs. MOFs are managed object files or sources. They are, um, it's basically a header file, like a C header file, that gets compiled into a BMF file, which is then the compiled version. Both can be imported by the Windows tool MOFComp. MOFComp can be used over SMB or physically on disk, and then those get loaded into Object Store. Previous versions of Windows before like XP or so, or around XP or so, and before, I should say, automatically compiled the MOF file if it was placed in a certain directory and then triggered. So that was a really easy way of persistence. That's roughly how Stuxnet did what it did, but via different means. Um, so consumers, they're things called temporary consumers, and then there's permanent consumers. Permanent consumer is basically a temporary consumer, but in addition to receiving the trigger and event, it's triggered for all events and stored in the core object file, which is literally called object.dat. And here's an example of a temporary, and I say that with quotes. Of course, you can't see that probably, but this will trigger when there's a sorry, a log event, which is any event log trigger, and then it'll write new event log has been written. Very cool. But that's where our capability comes. And so we're not writing this anywhere. It's not storing in the object file to trigger on its own, because the event, once it's disconnected from PowerShell, isn't going to be able to go anywhere. You can also just ask Microsoft, because they literally have all that documentation online. That's where you go. Here's an example of a MOF though, and we're writing to an event filter called bad, that with a consumer called bad, and the filter that combines the two is just going to reference both bads. So we can query on bad in this example, and it will show the bad stuff. That's very repetitive. And also the file name that it's writing is not good, but the contents contain bad. And from this example, though, you can see how everything filters and subscriptions builds together. And these three components that we saw way back when allow you to actually have all the those things triggered. You can specify the different query, and then when and what happens. You have to specify the spaces and things, otherwise it doesn't trigger correctly, but it's that easy. And helpfully, one of the interesting things that Microsoft did was when you try to compile them off without a auto recover, it gives you a warning. And what the auto recover does is specifies that it will be automatically restored if you're corrupted. And why this is helpful is because one of the ways to remove persistence is doing a recover. So helpfully, Microsoft told us how to persist, even more so than before. Now, the final thing on the MOFs is how to detect them. Now, from here, you can see we're querying a specific namespace with WMIC and the event filter. By default, there is the SEM event log. SEM event log 8, 10, 12, 4. Those are all malicious. If That's like a watermark minor variant. But for our particular cases, the bad one, you can see the SID that created it. That's the user account that I logged in as. I tried not to log in as administrator to make it more annoying. And you can see it's there and more visible. So at least you can see what user did create something. You don't know how or where they did it from, but you know who did it, which might be helpful. Um, and then you can see that there's the actual typo. I took the screenshot before I corrected it, but you can see the 5 where there's supposed to be a space there. And this event will never trigger because of that typo, but it is created successfully. And this goes to show you that there is no protections in WMI. You can do some very bad stuff and WMI will not stop you. For our filters, because we're only looking at the joint points between the consumer and the filter, the event consumer, you can see the joint point, and that's how you can actually identify stuff, is if you query on those, and you can look where they end up. You can see the built-in ones don't go out of root subscription either. Removing them is very easy. For this one, because it was just bad, we do a SQL-like query where we say anything that contains bad, delete. And you can see it successfully removes those events. So the object store is the most interesting part of WMI, and as a defender, this is where your bad stuff is going to be stored. This contains all custom MOFs, as well as all the persistence and some command activity that WMI persistence may execute. For example, in the picture below, I look for Win32, and you can see all the different components that are triggering and their paths. There are tools to parse it. It doubled up and overwrote the wrong one, but I will also post this at the end of this on the actual live portion, the two different tools. The WMI forensics Python tool is very good. There is an additional tool that can parse this from the FireEye team that is a little older. I believe they're actually made by the same group, but those two tools allow you to read the object file for content. If you do just pure strings on it like we're doing, you usually find something interesting, but it's a little hard to go through. So you usually need to use a hex editor to be able to identify it. But if you're thinking that something was compromised, you can just do find. I bet everyone here is now feeling a little bit underwater with how much information. And you're like, well, I wish I could just log all this. Well, the good news is you can. Here are the events that log. By default, event 5857 is the demo activity. It's very vague. I'll show you a screenshot in a second. You can enable tracing. Tracing is very helpful. The problem with tracing is that it doesn't provide a lot of narrow information on what was happening. That's where Sysmon bridges that gap. It'll show you that WMI happened. Sysmon shows you when the consumers and filters are created. And so here's that example of the event 5857, and it literally just says a DLL was loaded, WMI was triggered. That doesn't help you. As a defender, that really doesn't tell you anything that could have happened, or if it was a computer or a user or anything. So the challenge is, well, it doesn't track remote activity. The trace activity is helpful, but it wraps around very quickly unless you set it larger, and then that becomes unwieldy. If you find a backdoor, such as create backdoor.exe, you may see that it triggered, and you may see the user that happens, but it doesn't tell you where it came from if the user was on the system. Other forensic artifacts may, but if it's a fully remote attack, you have some more work to do. And so that's where you can come in to help limit your attack vector. Some of the best defense is turning off things you don't use. Do you need WScript? Do you need PowerShell? Do you need WMI remotely connected? If the answer is no on any of these, turn them off. Many AV tools also allow this in a much easier fashion than manually doing registry modifications, but we're not all that lucky. And then finally, you can set up App Locker to restrict what can run on the system. And then here's the screenshot of WMI again, where we can see the permissions that you can actually set. That's where this ties in together, but that's it. WMI in a nutshell is a very powerful tool that allows you to do a lot of querying, but you have to be very careful because the same tools that as an administrator you can use to get a lot of information and set things can also be used by attackers to do all sorts of interesting things that you don't want them to do. So if you have any questions, please stay around for the interactive portion that's hopefully happening at the end of this. And if not, follow me on Twitter and we can have a chat if you want. Anyway, thank you for coming to WMI Stole Your Cat. The cat's been found. They're just gone evil.